So solutions of differential equations. First, we want to know what the differential equation is. A differential equation is something like this, which is an equation, obviously. There is an equality sign here, and it involves your independent variable x. It involves y, which is your function, and the derivatives of y. So like y prime, y double prime. If you have an equation that involves the function and the first derivative, it would be called a first derivative, a first order differential equation. You may have a second order differential equation. So for example, something like this. Let's say y plus y prime plus 2y double prime is equal e to the power of x. So that would be a second order differential equation because you can see your independent variable x, the function, the first derivative, and the second derivative of the function is also involved in that equation. Now, how do you solve, or what is the solution of a differential equation like? The solution of a differential equation is going to be a function or a family of functions. That's the big difference between a differential equation and the other types of equations that you have seen so far. So, for example, if I give you a very simple linear equation like 2x plus 1 is equal, let's say 5, yes, then when you solve this equation, you're going to get x equals 2. That is the solution to this equation. So as the solution, you get a number. But with a differential equation, when you solve a differential equation, the solution is going to have the form of either a function or a family of functions. So for a problem like this, the question is, what should y be so that if I add up y and the derivative of y, I get x. So the solution is going to be a function or a family of functions that satisfy this equation. In this section, the solution is provided, and the only thing that you need to do is to verify that the solution works. So it's a first step to understanding and working with differential equations. Later on, we're going to learn how to solve one type of differential equations called separable. We're not going to go very deep into that. The differential equation itself is a very, very vast topic. So this section is about verifying the solution, the given solution to a differential equation. You will understand these explanations better if we just do example 1. So example 1, it says, show that this function f of x is e to the power of minus x plus x minus 1 is a solution to the differential equation y prime plus y is equal x. So this here is our y. And in order to verify this solution, I would just need to plug in the values into the equation and see whether it works or not. Just the same story when you have a linear equation like the one that I just gave as an example. If I tell verify that x equals 2 is a solution to this, what would you do? You would just plug in 2 into this. Say 2 times 2 plus 1 is 4 plus 1, so it is 5, so check. Yes? What about x equals 3? Is that a solution? 2 times 3 plus 1, that's 6 plus 1, that is 7. 7 is not 5, so no. That is not a solution to this. Yes? So same story here. We are given this as a solution. We need to plug in y. For y here, we need to plug in y prime into this and then see whether we get x or not. So we need y prime as well. Let me calculate y prime. y prime is going to be the derivative of this with respect to x, so it's minus e to minus x plus 1. I'm just using the chain rule here, using the fact that if I have e to the power of f of x, and I'm taking the derivative of that with respect to x, according to the chain rule, I get e to the power of f of x times f prime of x. Yes. So in this case, the derivative of minus x is minus 1. That's how I got this minus 1 here. Plus the derivative of x is 1, and the derivative of minus 1 is 0. So this is my y prime. Now I'm going to put y prime here, y into this, simplify, and see whether I get x on the other side. So let's do that. Minus e to minus x plus 1 for y prime, plus for y, I plug in e to minus x plus x minus 1. Now let's simplify that. This will cancel this. Plus 1 will cancel minus 1. Only x is left. So check. This is a solution to this differential equation. Is this clear?
Yeah.
Okay, great. Now, is this the only solution? As I said, in most cases, when you're dealing with a differential equation, the solution is a family of functions, not just one function like this. So in the next example, we're going to verify whether this family of functions, where c is any constant, is a solution to the same differential equation. So if y is defined to be c e to the power of minus x plus x minus 1, where c is a real number, it's a constant. It's a constant real number. Is this a solution to y prime plus y is equal x? The way you verify that is not different at all. I need y prime, so I calculate the derivative. I get minus c e to minus x plus 1. And then I plug in y here, y prime here. I simplify. I see whether I get x or not. So minus c e to minus x plus 1 plus c e to minus x plus x minus 1 is equal. These two cancel out. These two also cancel out. I get x. So check. Okay. Sometimes you are given a family of functions as the solution that you need to verify. You may be asked for one particular solution which satisfies a certain initial condition. A solution that has this form would be called a general solution. So it's a family of infinitely many functions, which is a general solution to this differential equation. Now, here you have an example where you're looking for the particular solution which also satisfies a certain condition. So example 3 uses the same differential equation but with a initial condition. So we have this differential equation, y prime plus y is equal to x. We also verified that y equals c e to minus x plus x minus 1 is a solution, is a general solution for this differential equation. Now, in example 3, it says, use the results of example 2 to find the particular solution of this differential equation that satisfies this condition. The condition y0 is equal to 0. This is another notation. Y0 is equal 0. This is another notation for f of 0 is equal to 0. Or another way of saying the same thing is that the function passes through the point, or the graph of the function passes through the point 0, 0. With this initial, and you have seen problems like this before. This is called an initial condition. This will help you find this c over here. So if I plug in, I have f of x is c e to the power of x plus x minus 1. If I plug in 0, I get c e to the power of 0 plus 0 minus 1, and that is supposed to be, according to the condition, 0. That will give me c, right? So e to the power of 1 is 0, c minus 1 is 0. That means c is equal 1. So the particular solution is going to be, if I replace c with 1, e to minus x plus x minus 1. That would be the one particular solution from this family of solutions that also satisfies the initial condition. Are we good? Okay, let me do some of the exercise, a few exercises from the book. From this section, you're supposed to do number 1 to 13. And then let me just see whether these, which ones you are supposed to do from 9.1. Number 1 to 11, then 13 to 17, and then 29 to 32. I'm going to do one of each type of problem, and then also do one problem from the web work, and we'll give you the rest of the time to work on the exercises. Okay. Okay, let's do number 3. It says verify that y is a solution to the differential equation. So you're given a differential equation here, y prime plus 2xy is equal x, and you're given the general solution to that. Y is 1 over 2 plus c e to the power of minus x squared. And you want to verify this solution. So I need to figure out what y prime is, and then plug in y prime here, plug in y here, and see whether I get x on the other side. Let's do that. Y prime is going to be, the derivative of this is going to be 0, and the derivative of this part is going to be c times e to the power of minus x squared times the derivative of the inner function, which is minus 2x, which I can also write as minus 2c x e to minus x squared. Is that clear? Okay, now let's plug in. This goes here, y itself goes here. So I get minus 2cx e to the power of minus x squared plus 2 times x, and then y goes here, 1 over 2 plus c e to the power of minus x squared. And let's simplify this, see whether we get x. Minus 2c x e to the power of minus x squared plus this times this, 1 over 2 and 2 cancel out, plus x, plus, if I multiply this 2, I get 2x c e to the power of minus x squared. That is equal, as you can see, these two cancel out, you get x. So, check. Very good. Okay, from this bunch of exercises, let's do the first one. Same story, you're given the solution, the general solution, and you're also given one initial condition. So using this initial condition, you will be able to find the particular solution, the one function from this family of functions that satisfies the differential equation, also satisfy the initial condition. y is cx squared minus 2x. The differential equation is y prime minus 2y over x is equal to, and the initial condition is y of 1 is 10. That's the same thing as saying f of 1 is 10. The same thing as saying the function passes through the point 110. So for these problems, it says first verify that y is a general solution to the differential equation, and then find the particular solution. Let's verify that. Y prime is going to be 2cx minus 2. That's the derivative of this. Now I'm going to plug in 2cx minus 2 minus 2 times y over x. Cx squared minus 2x. Let's simplify. I get 2cx minus 2 minus 2 times. Cx squared over x is cx, and negative 2x over x is minus 2. That gives me 2cx minus 2 minus 2cx, negative 2 times negative 2 plus 4. And if I simplify it, I'm going to get negative 2 plus 4, that's positive 2. And I was supposed to get positive 2. So check. We good so far? Now, let's find a particular solution that also satisfies this condition. If I plug in 1 into this, I get c times 1 squared minus 2 times 1. That's going to be c minus 2. That's supposed to be 10. That gives me c. So c is 12. So the one particular solution that satisfies this initial condition, as well as our differential equation, is going to be 12x squared minus 2x. Any questions? Okay. From this last bunch, let's do number 29. Same story here. It says verify that this function, that given function, is a solution to the given differential equation. Determine whether the statement is true or false. If it is true, explain why it is true. If it is false, explain why, or give an example to show why it is false. So it says this function here is a solution of this differential equation. Let's see whether it's true or not. This function, x squared plus 2x plus 1 over x, is a solution to x y prime plus y is equal 3x squared plus 4x. So I need to find y prime to be able to verify this. I get 2x plus 2 minus x to minus 2. Yes, because this here is like having x to minus 1. So the derivative of that is going to be minus x to minus 2. Now I can just plug in. I get x times y prime, 2x plus 2 minus x to minus 2 plus y, x squared plus 2x plus x to minus 1. And I simplify this, I am supposed to get the other side. If I get the other side, then the answer is yes, this is true. If I don't get the other side, then it's not a solution. Let's see what happens. 2x squared plus 2x minus x to minus 1 plus x squared plus 2x plus x to minus 1. Okay, 2x squared and x squared, that's 3x squared. 2x with another 2x, that will give me 4x. And minus x to minus 1 and plus x to minus 1 cancel out. So yes, I got the other side. 3x squared plus 4. So yes, this is true. This function here is a solution to this differential equation. Okay, so I also want to do one problem from WebWork, and then I will let you start working on these problems. So you should all see section 9.1. Let's do problem 1. Let y prime be 6x. Find all the values of r such that y equals rx squared satisfies the differential equation, because this is the differential equation. It involves a function. It involves the derivative of a function. So very simple. You just find y prime. If you take the derivative of this, so I see you cannot see my board. If you find the derivative of this given family of functions, you're going to get 2rx. And you want that to be equal 6x for all the x's. Yes? If this is true for all the x's, then that means 2r has to be 6. That means r is 3.